Now let's discuss the topic electric flux. Now see, we define electric field like this: electric field intensity at any point, that is the total number of field lines passing through unit surface area at that point perpendicular to that area. Now electric flux, that is the total number of field lines passing through the given area normal to it, that is called electric flux. Flux means something is passing through the given surface. That is the concept of flux. In standard 11th also we studied about the volume flux, mass flux, means something is passing through the given surface. Here electric field is passing through the given surface that we have to consider. So this one is electric flux. Now suppose first we consider the uniform electric field as shown in this figure. And in that, take a surface with surface area A, which one is placed normal to the electric field. So if surface itself is normal to the electric field, then area vector is always represented perpendicular to the surface. So area vector of the surface, that will be in the direction of electric field. So here, suppose at this particular point the electric field intensity is E. It implies that we can say now the number of field lines passing through unit area at that point normal to that area, that is E. So if number of field lines passing through unit area is E, therefore number of field lines passing through total area A is how much? So that is E into A, and total number of field lines passing through the given area normal to it, that is called electric flux passing through it. Okay, but see, always the surface is not perpendicular to the field. Suppose surface is a slanting one, means area vector of the surface is at angle theta with respect to the electric field. So if we take its component in the direction of electric field, so for this area vector, which one is making an angle theta with respect to field, have the component A cos theta along E. So A cos theta, that is representing the component of this surface which one is perpendicular to the field. So now here we can say the total number of field lines passing through the surface normal to it, that is EA cos theta. Suppose the surface is perfectly parallel to the field, means area vector is perpendicular to the field. So in this particular case, not a single field line will pass through the surface. Therefore, the flux passing through this one, that is 0. So now from all this one, we can generalize the equation for the flux phi, that is E dot A. Now E dot A, so that is EA cos. So EA cos theta. See, if area vector is parallel to electric field, cos theta, that is cos 0, that is 1. So we will get this particular situation. Then if the area vector is making an angle theta with respect to the field, then the flux passing through the surface will be obtained this one. And if area vector is perpendicular to the field, then theta equal to 90 cos 90, that is 0. So flux passing through the surface is 0. So we can write flux phi, that is E dot A. Flux, that is the scalar quantity. Clear? Now suppose the electric field is non-uniform one, and the surface under consideration, that is also odd even surface. So in that particular case, if you want to calculate the total flux passing through that particular surface, then how to calculate it? Again, we have to divide this surface into so many infinitesimal small elements. And that element should be considered such a small so that for each and every point on that surface, we can consider the electric field that is uniform one. Such a small element that we have to take in consideration. Now, suppose for this particular surface element under consideration, the electric field is E, its area vector that is delta S, and suppose here the angle between these two, that is theta. So flux passing through this particular element, that is delta phi equal to E dot delta S. So we can write E delta S cos theta. Now, if you want to calculate the total flux passing through this one, then very simple, we have to take the algebraic summation of all this. And when here we are taking limit delta S tends to 0, means infinitesimal small surface elements, then in that case, we can represent the equation of total flux phi by integration also. So integration over the surface E dot ds, that is the total flux passing through that particular given surface. And here the unit, that will be Newton meter square per coulomb. So this one is the concept of electric flux. Clear to all of you?